Hello, is it audible now? Okay, a very good evening to all of my dear students. I hope all of you are doing amazing with your preparations. कमाल की प्रिपरेशन चल रही है आप लोगों की और गेट जो अभी आने वाला है उसके लिए आप सब तैयार हैं. Yes, first of all, apologies for starting the class a bit late today. There were some technical issues and we were fighting with them, right? So things are all set to go live now. And I texted you in the chat section also that I'll be live in the next 5 minutes. Thank you so much for having the patience, everyone, right? Okay. So today's class is going to be very amazing because I'll be giving you the very conceptual questions. In today's class, instead of writing the numericals much, we will be writing the conceptual questions first. Because in the last 3 days, we discussed all the numerical questions. I gave you the approach to generate a mindset for the numerical questions. And as per your request, I have brought the questions of the foundation engineering today. Yes. So I hope that every one of you will be watching this session till the end and will be enjoying the questions of the foundation. Also, someone of you requested the questions of the consolidation, so I have brought the questions of the consolidation also. So today, this session is going to be the winding up session, and all the concepts which are remaining in the geotechnical engineering will be covered within today. Right? Yesterday I started solving questions in test series, sir, but that question is very differently. I'm losing my confidence, sir. Please try to understand, my dear students. The questions in the test series are always designed on the upper higher side. Always on a bit higher side. I have always been telling this to you. The test series are designed in such a way that it seems very difficult to the students. And if you are able to solve around 70% of the questions of the test series, that means you are doing fairly good. And if due to certain reasons you are not able to apply those questions, need not to worry. Keep applying the questions. Revise your concepts and move back to the questions. No need of losing the confidence. Just remember one thing, once you have all the concepts, there is no question which will be unsolved. You can solve any question on this planet. Yes. Who is the student? Islam. Islam, you can ask your doubt, bache. Only related to the subject for now, right? Because we are entering into the session. So I hope everyone has arrived. We have waited for around 2-3 minutes now. We will be entering into the session. The subject which we are discussing today is geotechnical engineering, right? And this is going to be the final session of the geotechnical engineering, covering all the remaining topics of this particular subject, right? Let us enter into it. Okay. So before I present the first question to you on your screen, I just want to know everyone. How many number of questions you applied yesterday? Very good. I did 5 tests of geotech having 25 questions and my highest was 23 out of 38. It's good. It can be considered good for now, Mayank. 75. Very good, Pradyumna. Chatu, 42. Mayank, what were your number of questions? 5 tests of geotech having 25 questions. That means 25 was the score of the questions. Islam, we'll do one thing. Bache, see, in our class, how things proceed, I'll tell you very clearly. Whatever your doubts are, students type it in the comment section. And as we move forward with the question, I explain all the doubts, right? So we will not randomly start any topic from anywhere that you came up with one doubt and I started solving that doubt and then we move forward. No, this will be a huge wastage of time. If suppose there are 18 students and they are bringing their different doubts, the main topic will be left, right? So your doubt will be covered, but within the questions only, right? Islam, I have noted your down. I have noted down your doubt and I will cover it within this session. Alright, bache? So have patience for now. Okay? Now, 50 questions by Bhageshri, 60 questions by Vivek Raj. Very good. See, all of these students who are applying the questions, I'm telling you very clearly, my dear students. Now, this application of the questions will not go in vain. This will not go waste. This will be very fruitful when you will be going to the gate examination. You will be rewarded with the marks. This hard work is going to get converted into the marks directly, I'm telling you. So, very good. Tomorrow's target I'm giving you. I left amazed that after studying so hard, I got 292 out of 2000 as my best rank. Mayank, see, I have been teaching you from last 3 years only, I guess, and I do not even remember actually from which batch are you, or if you have studied any subject from me. I doubt it. But see, whatever the past 3 days of studies were, I am sure of one thing, dear student, that you miss. This is not to demotivate you. I'm telling you, you miss a bit conceptual clarity of the concepts, and this may be the reason that your rank is going this much, right? But this will improve, and this is not a bad rank, I'm telling you. This is not a bad rank. If you keep applying this test series, you keep applying the questions till the examination, this is going to improve. So stay confident, keep applying the questions, and your rank will definitely improve. Okay, let us enter into the first question of the day. Are you ready, everyone? Are you ready for the first question of the day? So I'm going to start this right away. The first question of the day is on your screen now. On your screen now. On your screen now. Try to solve it, everyone. हाँ निकल जाती है नहीं मैं don't worry, I'll give you a solution for that also. Don't worry, I'll give you a solution of that also. आज मैं आपको बताऊंगा कि कौन से क्वेश्चंस लगाने से आपकी रैंक इंप्रूव होगी. ठीक है मैं today I'll be telling you which questions should you apply to improve your rank. Okay, after this question only I'm going to tell you, so apply this question first. Anyone with the answer? Anyone with the answer? Islam? No, bache, your answer is wrong. Pradyumna, very good. Pradyumna, very good. Vivek Raj, your answer is again wrong. See, Pradyumna was my student, I remember. And those who have studied the subject conceptually, they will be able to answer it very clearly, right? I mentioned these notes separately in your class notes. Anyways, who is it? Shri Nandana. Okay, very good. So the right answer for this particular question is A. The right answer for this particular question is A. But how? How? I'll just tell you, everyone, don't you worry about it. The right answer is A. Now, before I explain this question, I'll bring your focus to this particular word, which is named as consolidation. Which is named as the consolidation. Now, let's write a few points about the consolidation here, right? Yeah, this seems as the least favorite subject of the students across India because they no list, they have list content for this particular subject. Once they have good content for this particular subject, man, it will become their more favorable, right? It will become more favorable. It will become more favorable. Okay, man. You can see the Pradyumna and those students who attended the live classes from me, now they have improved their concepts a lot. When they were in the beginning of the classes, they were hardly able to answer very good questions. Okay, anyways, just coming back to the concept for now. Consolidation. What is the meaning of this term? What is the meaning of this term? I'll just write the few words. I'll just write the few concepts from where he can ask you the question of the consolidation topic. Right? Number one, consolidation is compression of the soil. Can I say that consolidation is the compression of soil? Can I say this? You people just type, you people have to just type yes or no. If you agree to me, just type yes. If you disagree, you can type no. And then I will explain that particular thing only, right? So consolidation is compression of the soil. Number one. Number one. Very good. Now Chetu is typing that it is the reduction of the weights. I can simply write that decrease in volume of soil. This is nothing but your decrease in volume of soil. Volume of soil. This is the second thing. I can write this. Okay. Now, what is the third thing? Third thing. Compression of the soil, decrease in volume of the soil. And how this decrease in volume of soil is occurring? How this decrease in volume of soil is occurring? Escape of pore water. Escape of pore water. But please mind my words. Each of these points is going to get converted into the questions of different states or different like engineering services or GATE. Every point is being asked as the question. So you have to be very serious while writing these points. Okay. So first is the compression of the soil. Second is the decrease in volume of the soil. Third is the escape of the pore water. I hope you agree with all the 3 points. Now fourth. If the pore water is escaped, if the pore water is escaped, the effective stresses will increase or decrease. The effective stresses. Now, the very first thing to you is, what is the meaning of the effective stresses here? The meaning of the effective stresses here is stresses between the grains. Stresses between the grains. Now, whatever are the stresses between the grains, if I have removed the pore water from it, this effective stresses will increase or decrease? Tell me, everyone. This effective stresses will increase or decrease? Tell me, everyone. This increases. This increases. So effective stresses increases. So I can write here effective stresses. Effective stresses increases. Effective stresses increases. Now, if the effective stresses are increasing, what will happen next? The fifth point of consideration: compression of soil, decrease in volume, escape of pore water, effective stresses increases. Effective stresses increases. Now, this consolidation phenomena is nothing but, I can say that this is a volume reduction phenomena. Volume reduction phenomena. If the how the volume is reducing, particles are coming close to each other. Particles are coming close to each other. How? I'll tell you. Close to each other. Now, suppose one thing is there. Suppose, please understand, these are the two particles. These are the two particles, right? These are the two particles. This is your one particle, right? This is your one particle. This is your second particle. They were forming together the soil. Earlier, between the place between them, space between them, or the void between them, they had the water. Once the water is eliminated, they will come close to each other. Why? Because the effective stresses have increased. Why? Because the pore water has escaped. Why? Because there is decrease in the volume. Not decrease in the volume automatically means that they are coming close to each other. Yes or no? Yes or no? Yes or no? Yes, sir. If they are coming close to each other, Chetu, I'll take you down. Don't worry about that. If they are coming close to each other, right? If the effective stresses are increasing, from here, let us see the options now. Is a function of the effective stresses. Consolidation in soils is a function of effective stresses. Number one. Number two, does not depend on the present stresses. Does not depend on the present stresses. It depends on the present stresses. It depends on the present stresses. Now, is a function of the pore water pressure. Is a function of the pore water pressure. Is it a function of the pore water pressure? Last is a function of the total stresses. Now, have I mentioned anywhere the total stresses which you were saying? No. What we have written the effective stresses. So this answer belongs to A only. Is this clear to you now? Is this clear to you now? This entire question. Can I take your doubts? Can I say? Can I take your doubts? Can I take your doubts? You can simply, if you just want to assume an example of it now, you can simply consider. I have always been given the example of the rasgulla. Rasgulla. Do you eat the rasgulla? Chetu, have you seen the rasgulla or sponge rasgulla in particular, or a sponge, right? What happens? It has the water present into it, but if you are pressing it, if you are pressing it with your hand or with your fingertips, what will happen? The sugar syrup will come out of the rasgulla, right? And what you will be left with? You will be left with something where the water has came out and the volume has been reduced. So that can be the case. That can be the example. Chatu, that can be the example. Yes or no? So I hope this example makes it more clear now. I hope this example makes it more clear now. Chatu, shall we proceed to the second question? Okay. Now, let us move to the question number. Let us move to the question number 2. Even a better question. Solve it. Even a better question. Solve it. Even a better question. Try to solve it. Try to solve it, bache. Everyone. See, these are the conceptual questions, Mayank, which I wanted to discuss for you people, right? Because I felt that you people are still good at numericals, but you people are very, very normal or casual at the conceptual questions. You just consider that these are easy questions and you leave them. But these are the questions which take you to the negative marking, right? So just give me the answer for this particular question and then I'll solve it for you. Then I'll solve it for you. Try to solve it, everyone. Try to solve this particular question. Then I'll be coming to the screen and we'll be solving it. Try to solve it. This is just the second question of the day. I have brought so many questions for you today. I even do not know the exact number of the questions, but it is even greater than tomorrow, greater than yesterday. Whatever the number of questions we applied yesterday, we will apply more questions. Okay. Anyone with the answer? Enough time for this question. I'll be solving it now. Just see this. Let me read the question for you, all of you. A double draining clay layer 6 meter thick. I will repeat it. A double draining clay layer 6 meter thick, right? Settles by 30 mm in 3 years. Settles by 30 mm in 3 years under the influence of a certain load. Under the influence of a certain load, its final consolidation settlement has been to be 120 mm. Its final consolidation settlement has been 120 mm. Right. If a thin layer of sand having negligible thickness is introduced at the depth of 1.5 meter below the top surface, the final consolidation settlement of clay layer will be. So this is the question. Anyone with the answer? Anyone with the answer? Mayank, very good. Mayank has given the answer. Okay, very good, Mayank. I appreciate at least you tried it. Now I'll just give you an example of it. Right? I'll just make the diagram and I will explain it to you. Don't worry. I know you people are, some of you are beginners and you need the conceptual clarity of it. What is he saying? He is saying that there is a clay layer of the 6 meter thickness. This is the clay layer having the 6 meter thickness. 6 meter thickness. Now, this is the case number 1. In the case number 2, what he did? In the case number 2, what he did? He did thin layer of sand having negligible thickness is introduced at a depth of 1.5 meter. Now, what we will do? We will take the same sample and we will take the same sample. Total was 6 meter, right? The total was 6 meter, but after a depth of 1.5 meter. After a depth of 1.5 meter, we introduced a very thin layer. Now, what will be the depth left below it? What will be the depth left below it? Now, this is going to be. Now, this one is 6 minus 1.5. That is your 4.5. Though this is not seeming like 4.5, but you will have to assume that this is your 4.5 meter, right? Now, very good, Pradyumna, very good. So, seeing the diagram, you are able to solve it now. Seeing the diagram, you are able to solve it now. Now, please understand. I will just give you one statement and things will be clear to you. Please understand. Please understand. The final consolidation settlement. The final consolidation settlement depends upon the total thickness. Now, total thickness for this is 6 meter. The total thickness for this is 6 meter. The final, I will write it here, final consolidation settlement depends on total thickness. Now, if we are inserting, please remember, if we are inserting negligible thickness layer in between it, are we changing the total thickness? No, we are not changing the total thickness. Since we are not changing the total thickness, we are not changing the final consolidation settlement. So we are not changing the final consolidation settlement. So final consolidation settlement in this case was 120 mm. So in this case also it will be what here? 120 mm. It will be a 120 mm. So where is the answer? The answer is this only. Is it clear to everyone? Is it clear to everyone? Now let us discuss it more. Let us discuss it more. What changes we can make to this question? He can ask you that which has the more rate of getting drained? Which has the more rate of getting drained? That means which of these two specimens will get drained quickly? Rate of drainage. So please understand, you will have to understand before that how these two samples are different. Thickness is same. Thickness is same. Thickness is same. So what is different here in these two samples? If the thickness is same, what is different here in these two samples? The difference here is in the drainage path. You have to understand this. The difference here is in the drainage path. They differ from each other by the drainage path. Now you will tell me if this is your first specimen and this is your second specimen. Which of the following has more drainage path? You will be telling me which of them has more drainage path. Please tell me, one or two. Which of them has more drainage path? Very good, Islam. Very good. Which of them has more drainage path? Tell me. Very good, all of you. So it has more drainage path. Since it has second has more drainage path, the rate of drainage is quick. The rate of drainage is quick in second. Quick in second. Is that clear to everyone? Is this entire scenario clear to everyone? Will you be able to apply such questions in the future? Will you be able to apply such questions in the future, everyone? Tell me. Clear? All right, very good, very good. Now, let us move to the question number 3 of the day. We have done 2 questions of the day. Now, let us move to the question number 3 of the day. Please ensure it. See, uh, Nilesh Sahu wants to ask how many times quick. Nilesh, we will cover, and Pradyumna, for you also, we have a different question. I have chosen the questions in such a way that we are starting from the beginning and the question and the concepts will keep on piling up. So next doubt or next question is covering all your doubts. So I will just suggest you people to have a patience for the next few minutes so that you will be able to understand whatever your doubts are. Okay. So let us enter into the question number 3 and cover all your doubts. Okay, Pradyumna and Sahu? All right, Prachi. So just see the question number 3. This is the question number 3. And questions will be coming which will be covering your doubts. Okay, bache, Nilesh, I have seen Johan, I have seen your doubt, and Islam, I remember your doubt also, bache. Okay, I remember your doubt. So just let us keep moving because there is no point of wasting the time here because the same thing has to be covered in the future also, right? Let us move to the next question. This is the next question. Please try to answer this question, everyone. Please try to answer this question, everyone. All right, all right, all right. I have given enough time for this question. Now let us start answering this question, okay? Let us start answering this question. What does it mean? I'm coming for it. Now, very good. All of you have given the right answer, I guess. Very good. Now, please answer. The curve fitting methods are used to find the what are used? Which methods are used? Curve fitting methods. I'll just give some additional theory to you people. Those who are the beginners. Curve fitting methods. Curve fitting methods are best suited, are used to find the coefficient of consolidation, right? They are used. What are the two methods? What are the two curve fitting methods? Anyone? What are the two curve fitting methods here? The two curve fitting methods are Taylor's square root of time. Taylor's square root of time. Square root of time. So you can just complete it. Taylor's square root of time, right? And the second method is Casagrande's logarithmic of time. Casagrande's log of time method. So these two are the curve fitting methods which are used for the consolidation coefficient, right? Okay, okay. Now, shall we proceed? Shall we proceed to the next question, everyone? So what is the right answer to this question? What is the right answer? All of you have given the right answer. So this is just a basic question which everyone knows, okay? Now, this is the answer. See the next question. This is the next question. Please answer it very carefully, everyone. This is the most conceptual question. You should be answering it very quickly, everyone. All of you here, come on. Right, I'm starting it. Very good. See, if it is a normally consolidated, see, there are two types of curves. I'll write here only. If it is a normally consolidated clay, it will be a straight line. If it is a over consolidated clay, it will be a curved line. It will be a curve. Right? So this is the entire scenario of normally consolidated clay and the over consolidated clay. So here this curve belongs to the over consolidated clay. All right. Here this curve belongs to the over consolidated clay. Clear? Let us move to the next question. This is the next question. Tell me quickly. This is the next question. Take your time and tell me the answer. Tell me the answer. Tell me the answer, everyone. Take your time and tell me the answer. Yes, who is ready with the answer? Who is ready with the answer? Someone is saying B, someone is saying B, someone is saying A. Hmm. Hmm. All right, I'll just tell you, everyone. I'll just tell you what is the concept of this question. Islam, very good. That is correct. Chatu, that is correct. Anaga Babu, no beta, this is wrong. And Manju Saini, this is also wrong. Okay. So I'll just cover this for you and don't worry. Tell me something, everyone. Tell me something. This entire fill, we gave a name to this fill. Now this entire fill will act as what? The entire fill will act as what? We used a term for this, a particular term for this. The fill will act like a surcharge. The fill will act like a surcharge. Now, after giving this hint, I will just read the question for you once, right? At a reclamation site for which the soil strata is shown in the figure, this is the figure, a 3 meter thick layer of fill material is to be laid instantaneously over the top surface. If the coefficient of the volume compressibility MV for clay is this, the consolidation settlement of the clay layer due to placing of filling material will be. Now, what they have done, they have put this layer. They have put this layer. Now, this layer will act as what? This layer will act as what? This layer will act as a surcharge. This layer will act as a surcharge. So the fill material or fill weight will act like a surcharge. So surcharge value Q will be what? The surcharge value Q will be equal to what? 3 meter into 21. So this Q will be 3 into 21. So what is the value coming out to be? What is the value coming out to be? This value will come out to be, tell me everyone, this is 63 kilopascal. 63 kilopascal. Now, the next step in this question will be, now you have calculated the surcharge already. So what he is asking you? He is asking you the consolidation settlement of the clay layer due to the, now due to the placing of this fill material, what would be the consolidation settlement of the clay layer, right? So what would be the consolidation settlement of this clay layer? So what is the formula to be used? We have to calculate the settlement. Right? Now the settlement can be calculated by a very simple formula, that is MV into H into MV into H into, next is your, there are just three parameters. Which are used for the calculation of this, right? What are the three parameters which are used? Next is your, so delta sigma should also be there. So put the values, all the values are given to you. Sir, senior section engineer का exam, but I cannot comment on this, right? We are here to apply these questions for the gate, right? So this session is dedicated for the gate. So just solve these questions. So value of MV is 2.2. Units you can focus on. What are the units, right? So what is the value of H? What is the value of H? Which H has to be considered? H naught has to be considered. So what is the value of H naught? Who's going to tell me? The value of H naught is 10. So this value of H naught is 10 into. And now unit conversion also you have to take care of. Now this delta sigma has come out as 63. Now into 10 raised to power minus 4. What is the answer coming out to be? What is the answer coming out to be? Tell me. What is the answer coming out to be? What is the answer coming out to be? You have written everything, all the data you have. So just, very good Islam, this is going to be 10 only. So this is 138.6 mm. Very good. So what is the nearest answer to the 138.6 mm? If this is coming out to be 138.6 mm, what is the nearest answer to it? The nearest answer is your B, right? I hope this question is clear to everyone now. All right. Shall we proceed? See, I read the question, I explained the question, I explained the answer. This must be clear now. There should be no doubt about it. There should be no doubt about it, right? Proceeding further. Okay. The next question for you is, this is the next question. This is your next question. Now, someone asked me how much time faster it is, if thickness is this, if thickness is that. Now, this question will make the clarity over it. Whose doubt was it? Johan, you asked this doubt, Pradyumna, or someone else asked this doubt? So that doubt will be covered here. No, Pradyumna, H naught will be the thickness whose consolidation is asked. The consolidation of this layer only has been asked, right? The see what is asking the consolidation settlement of the clay layer. So initial thickness. So what is the initial thickness in your words? If you want to call it the initial thickness, this is only the initial thickness, no? Or this is the thickness whose consolidation settlement has to be considered. So we will consider this only. I hope this is clear. See this everyone. Solve this. Someone asked me the doubt related to the how much time it will be. I'll just tell you. I'll just tell you. मैं था साबू था तो साबू I'll explain it बच्चे. Now you can see the note. I'll just give a note. अभी देखो वहां पर भी टाइम खराब होता, अभी यहाँ भी होता है. इससे अच्छा एक ही बार में कवर हो जाए बच्चे, है ना. अच्छा, anyone? Mayank, I'll take this doubt after this question. Will that be fine? If I take this doubt after this question, I have noted it. Now, you will just, no one is answering this question, so I'll just write a note. Wherever your notes are, just add a note to your notes. What is the note? Irrespective of the thickness. Irrespective of thickness, the two-way drainage, is always how much times? Who is going to tell me? How much times? Who is going to tell me? Is always 4 times faster than one-way drainage. Is it clear to you? Sahu, your doubt is covered. And everyone, now you can answer. What is the right answer to this question? The right answer to this question is B. You see this question? This is the question. And this is the right answer. And this is the explanation. Okay? Alright, everyone? Alright, everyone? Okay, coming back to the doubt of the man. Coming back to the doubt of man, I hope this is clear to everyone. This is the right answer. And this is the doubt what Mayank is asking, right? Now, Mayank, let us read the question and then I'll take it out. At a reclamation site for which the soil strata is shown in the figure, a 3-meter thick layer of a fill material is to be laid instantaneously on the top surface. If the coefficient of volume compressibility MV for clay is this, the consolidation settlement of the clay layer will be what? So what you are asking is, sir, due to the instantaneous loading, delta sigma is 0. Then I will tell you, man, we are considering this as a surcharge. This fill material is acting like a surcharge. Now, which case do you remember where the water was present or the surcharge was present over a layer and we considered the surcharge as 0? Do you remember any case where we considered the surcharge as 0? You should have seen the words very carefully. I said that this is acting like a surcharge. Now, this surcharge is never going to, whether it is instantaneously or it is laid gradually, we will never be ignoring the impact of the surcharge. This is why we have not considered it 0. Okay, man? Is it clear? Shall we proceed to the next question? All right. So we are proceeding to the next question, which is question number 7 of the day. This is a common data question. This is a common data question. Yes, Pradyumna, need not to see that again and again. No need to see that again and again. Okay. You already have follow your notes, Pradyumna. I have given you the notes. Okay. Islam. Yes, sir. Clear now. If water is present, then Islam. Then you will consider what Mayank said. Okay. Then you will consider for the instantaneous. We will consider this. Okay. Now, please understand this. Please understand this and solve this. Islam, solve this question. Your doubts will be covered. You people just keep solving the questions and I'll clear your doubts. Okay. See, this is what happens. Now, doubt of Mayank is clear, but it created doubt in other people's mind. Isn't it, Mayank? So, this is what you wanted. सबके दिमाग में थोड़ा थोड़ा कीड़ा डाल. And now you moved. This is not good. Like Islam, solve it. I'll come back to this. This is the common data. Seen the data. Now solve the question. This is the question. Initial void ratio of the clay layer is. You have to calculate initial void ratio of the clay layer, right? For this data. Initial void ratio of the clay layer. Solve it. Solve it. Solve it, everyone. If you remember, we covered some thing on the log scale. If you remember, we covered a few things on the log scale. Do you remember this? The log graph was considered for a few concepts. Do you remember this? All right. I'll just give you the graph first for this question, right? I know many of you will not be able to solve this. Let me solve this for you. Let me read the question. The question says, all right. Question says, this is a common data question. The average effective overburden pressure on 10-meter thick homogeneous saturated clay layer is 150. Consolidation test on an undisturbed soil sample taken from the clay layer showed the void ratio decreased from 0.6 to 0.5. Now these are the two values of the void ratio given to you. These are the two values of the void ratio given to you. Mayank, very good. Vivek Raj, very good. Islam, very good. I appreciate that all of you did this because I have given you the hint also about this. Now, by increasing the stress intensity from 100 to 300, G is this. What will be this is the data. Now, the initial void ratio of the clay layer is. So, you have answered this as the correct answer. I'll make a diagram for you people for the graph first and then we will start solving it. What does the graph say? Suppose this is what we take on the y-axis. Who's going to tell me what we take on the y-axis? This is the value of E and this is the value of log base 10 sigma dash. So we consider log base 10 sigma dash on the x-axis, right? Here. Now, what are the values under consideration here? The values under consideration here are, let me check. The first value under consideration, this is the curve, right? Suppose this is the curve, right? Suppose this is the curve. Now, what does this curve say? This curve says that this value is this value. Sorry. Now, this value is your 300, right? And the initial value, what we had was 100. Now, this is your 100, right? And this is your 300. Now the values corresponding to it, the value of the void ratio corresponding to it and the value of void ratio corresponding to it, it's already given to you. Is already given to you. What are the values given? The first value is 0.5. The second value is 0.6. But you have to calculate, this is the point, right? This is the point. Now, you just have to calculate the value of this point E. Now, those who have studied this conceptually must be knowing the very simple formula, right? What is the value here? This value is 150. Okay. So those who have solved it conceptually should be knowing the formula, that is very easy. How do we calculate the value of CC? How do we calculate the value of CC? How do we calculate the value of CC? That is your CC is your 0.6 minus 0.5 upon log base 10 of, in the numerator what we take, the higher value or the lower value? The higher value or the lower value? We take the higher value, that is 300 divided by 100. So what is the value coming out of this CC? The value coming out of this is 0.21. 0.21. Now, what is the another formula? This is a very popular and very easy type of concept. So need not to worry about it that I'm doing some rocket science, right? There is no rocket science. This is a very basic formula. Now this is equal to 0.21. We have the value of this, right? If we have the value of this, what it will be? This will be E minus 0.5. E minus 0.5. Now what will be the value? Log base 10. In the numerator, what we will have this time? We will have, in the numerator again we will have 300. In the denominator we will have 150 this time. So what is the value of E coming out? The value of E will come out to be, who's going to tell me? It will be somewhere between 0.5 and 0.6. This will be 0.563. Now, this is something which you can solve conceptually. This is what we have solved conceptually, right? Talking about solving it without making any calculations. How can you solve it without making any calculations? How can you make it without calculations? When you see this graph, understand this. When you see this graph, you know that this is a value. This value has to be between 0.6 and 0.5. This value has to be between 0.6 and 0.5. Can this value be 1? No, this value cannot be 1. So this value cannot be 1. Why? Because this value, just a second. This value cannot be 1 because this value has to be between 0.5 and 0.6. But if interpolation is fine, Pradyumna, forget about interpolation. This is just a trick, right? Now, can this value be lesser than 0.5? No. If you are interpolating a value between 0.6 and 0.5, this value cannot be this also, this cannot be this also. So what is the left value? This is this clear to you? But this is a trick, and as tricks are not always applicable, this is always also not always applicable. Trick has limitations, but in this question, there was no need of performing the calculations. Yes, this is you can call this as elimination method, but there is no such method in Islam. This is just a trick, bache. And trick are correct 99.99% times they are correct, but 0.001% chances are there that they may fail. Okay, bache. But so I have given you the conventional method also, trick also. Is it clear to everyone? Shall I show you the next question on this data? Shall I show you the next question on this data? Alright, see the next question on this data. You have to calculate total consolidation settlement of the clay layer due to the construction of a structure imposing an additional stress intensity of this. There is an additional stress intensity of this. There is an additional stress intensity of this bache. Now you will have to calculate the total consolidation settlement of the clay layer using this data. Solve it. Solve it. Solve it, everyone. Solve it. This is going to be the question number 8 for the day. Today's questions are more conceptual. They are more conceptual and they are more prone to be asked in the examination. We have not entered the foundation even now, right? We will apply some questions of the foundation also, okay? Someone has answered Anaga has answered, I guess. Anaga, Bachir, what you have answered? You have answered 492 mm. Okay, let others also answer. Let others also answer. Now, choose the most appropriate answer. Choose the most appropriate answer, Bachir. Anaga, choose the most appropriate answer. Mayank, choose the most appropriate answer. See, I'll just tell you what is the formula to be used here. Islam has given the exactly right answer. Islam has given exactly the right answer. Okay. Now, let us start solving it. I will solve it here only. No need to take some extra page or something. I'll just write the formula here. You already have all the data. You already have all the data, so you got to. Okay. So what we are supposed to calculate? We are supposed to calculate the data of the settlement we are calculating now. So this SF is going to be H naught. This SF is always going to be, you can just see the formula. Those who are not able to solve it yet, just see the formula and start solving it with me, right? So SF is equal to H naught into CC upon 1 plus E, right? 1 plus E. Now, you have all these parameters. E naught. We will be using the E naught. You have all these parameters. Now, what we will be using? We will be using the log base 10 of log base 10. See, on the log scale, what we used the stresses on the log scale. What we used the stresses on the log scale. So it will be sigma dash naught plus delta sigma upon sigma dash naught. Now, do I tell you what these values are? Do I tell you what these values are? Just write these values, right? I'll write the values also. What are the values? The value of E naught is, this is what will be calculated, 0.563. What is the value of H naught? What is the value of H naught from the previous data? Those who have solved it are going to tell me. This is 10 meter. Now, what is the value of sigma dash naught? Sigma dash naught is sigma dash naught. This is the value corresponding to the E naught. This is the value corresponding to the E naught. So this is your 150. What is the value of delta sigma? Who is going to tell me? Delta sigma. Delta sigma. So here, delta sigma dash is here. Which value we chose as the so this value was 200, additional value. This is the additional value. So you have all the data now, solve it now. You have all the data now, solve it now. Since you have all the data, get me the answer. What is the right answer for this question? When you will put all the values, you will get D as the right answer. Is it clear to everyone? Is it clear to everyone? Shall we proceed to the next question? Shall we proceed to the next question, everyone? Okay, see the next question. Just simple formula based question it was. This is question number 9 of the day. So this is going to be the first question of the day. From which topic? From which topic? I wish we had all the time with us and we could keep solving this, but since time is very less, we will have to make the selective questions only, right? We have to make the selective questions only. So just solve this. This question is from the pile foundation topic. This question is from the pile foundation. I'm writing it here. This question is from the pile foundation. See there, this subject is a bigger subject, right? So with this limited time, you asked me two topics to cover today. One was your consolidation and second is your pile foundation or foundation. So consolidation I have already covered. Now this topic is your CA. What about others who are not able to answer it? Huh? Okay, what is the question? Just see this. The question says, in which of the following conditions is the pile system shown in the figure highly inappropriate? Which is inappropriate? Can't you tell me? Come on, can't you tell this? Can't you tell this? This is the easiest question I can ask you for today. Come on. That means you do not know even the basic things about the pile foundation. Please try to understand. Baba, forget about the skin friction. No, forget about the skin friction. See, you just understand. I'll just tell you, and you will never forget pile from today. A pile looks like this. A pile looks like this. This is a pile foundation, right? Over which the entire building is going to rest. The camera will show you more clearly now. Okay, listen to it now. This is a pile. Okay. Now, so this is a pile. What you can see on at below the pile, what we have? We have a tip sort of surface. Now, this tip, please understand, you will rest this tip on a softer surface or on a rigid surface. You will rest this on a clayey surface or a dense surface. Tell me. Please understand, the pile rests on the bottom. This pile rests on the bottom, and all the loads of this pile are transferred at the bottom only. So the load where the final load is transferred, that place has to be very strong. Yes or no? That place has to be very strong. So always in the pile foundation, the base has to be very strong. So you just see this. If you consider all the systems here in this particular diagram, this pile is ending in a soft clay. If a pile is ending in a soft clay, the entire system is supposed to fill. Yes or no? Yes or no? Very good, Islam. Yes or no, everyone? So this is the most inappropriate system. Is this clear to everyone now? Okay, we are proceeding to the next part. We are proceeding to the next question. This is your next question. It is a true false question. So just solve it. Just solve it. Now, how many of you knows the bulb formation? How many of you knows the bulb formation? the bulb formation. How many of you know this? Tell me everyone, waiting for your replies. Under-ringed piles? Okay. False. Please understand, this is false. Why? Please understand, this is false. This one is false. Why? See, the bulb of this bulb is the bulb of pressure under a stripped footing. How it is shown? This is a stripped footing. How many of you have seen this formation? How many of you have seen this formation? A lot of you, and almost all of you, right, have seen this formation. Now, this formation, the bulb is formed in the direction of width, not along the length. So, you can simply write here, bulb forms in the direction of width and not along the length. Is it clear? So what is the appropriate answer? The appropriate answer is already with you. False. Moving to the next question. This is the next question. Tell me the right answer. Tell me the right answer, everyone. Tell me the right answer, everyone. And I'll give you the right concept for it. I'll give you the right concept for it. Once you solve it, I'll give you the right answer for this. Okay. Please understand. Very good. Very good. Please understand, if you consider your piles, if you consider your pile footing, these piles are of two types. One is the end bearing, another is the friction piles. Now, for the end bearing, I did show you that it has to rest on a very good surface so that load is transferred here. But in the friction piles, the load is transferred along the skin of the pile. So this works as per the skin. Now, what is the question? For the following question, friction piles are also called floating piles. So they, even if they are not resting anywhere, these piles may transfer load by the skin, and they are also called as the floating piles. I hope this is clear to everyone now. So this is true, right? I have explained this. Moving to the question number 12 of the table. Please answer this. Please answer this question. Very good, all of you. So, a negative skin friction occurs when the surrounding soil settles more than the pile, right? Why? Please understand. I'll just write it here. If the surrounding soil settles more than the pile, it applies a negative drag, or it applies a downward drag. It applies a downward drag. It applies a downward drag, leading to negative skin friction. Negative skin friction. So what is the right answer for this, everyone? What is the right answer for this, everyone? The right answer for this is B. Please ensure environmental engineering is on the way, right? So check the dates for the environmental engineering of this core booster, and we will be discussing all the details of environmental engineering there, right? Okay. Now let us proceed to the next question. That is question number 13 of the day. See this question number 13 and answer this. What is the value of bearing capacity for cohesion? NC for piles are per as per Meyerhof is taken as. Please answer this. Please answer this. No. Please understand, they have asked for so write down NC is equal to this. NC is equal to 9. This NC is equal to 9 for piles in the clay. For piles in the clays, if the piles are in the clays, we make the NC is equal to 9. So the right answer is C. Why you answered this as 5.14? This is just to confuse you, right? This is just to confuse you, this 5.14, okay? Let us move to the question number 14. This is the question number 14. Well foundation is commonly used for what? Tell me. Well foundation is commonly used for what? Tell me. This is a good question. This is a good conceptual question. This one is a good conceptual question. Tell me who is going to tell me. Very good, Islam. Very good. See, I'll tell you. No. But please understand. I'll tell you. These well foundations, can withstand scouring. They can withstand scouring very easily. And since they can withstand scouring, scouring is maximum in the running water. Scouring is maximum in running water. Maximum in running water. So wherever we have the running water or in the bridges, we can use the well foundation as the foundation, suitable foundation. Is it clear to you? Shall we proceed to the next question? All right. So the next question is question number 15 of the day. This is the question. The group efficiency of the piles. The group efficiency of the piles. The group efficiency of pile group. Tell me everyone. You have to find the incorrect answer here. You have to find the incorrect answer here. The incorrect answer here is D. This answer is incorrect. Rest all the things are matching to the group efficiency of pile group. Right? Why? Because I'll tell you why this is the right answer. I'll tell you. For cohesionless. For cohesionless. Now see, this is the concept. For cohesionless soil, I hope you can say this. For cohesionless soil, the value of group efficiency Ng is less than 100. Is less than 100%. And for cohesive soils, this value of G is greater than 100. So it is just given opposite. In this option, it is just given opposite. I'll explain. If you want me to explain, I'll explain. Now, see, for cohesionless soil, this this efficiency of the group is less than 100, and for cohesion, this is greater than 100, right? So, this is why we are choosing this, because here it is given just the opposite of it, right? Will always be less than 100%. See, this can also be considered correct. Who said this? Mayank. This can also be considered wrong, but this is not 100% wrong. This is not 100% wrong, because if I consider the cohesionless soils only, then this becomes the correct statement. Right? But this is always incorrect. So this question was more about choosing the most appropriate answer, right? Or which answer is more wrong. Okay. So what is the right answer for this? You got this, everyone? You got this, everyone? You got this? Now, this is the one approach, but this was again a very contradictory answer. Now, please try to understand this. Mayank, if you say that this is wrong, you should be saying that this is also wrong, because it will be always greater than 100. This is also wrong. It will be always less than 100. This will also be wrong. If we say that this is also wrong, because we have already mentioned this, right? So the most appropriate answer for this particular question, which was in fact the contradictory answer in that time when it was asked, the right answer will become C, because all other statements are wrong. It may be less than 100, it may be more than 100. As we have seen this, it may be less than 100 for cohesionless soils, it may be more than 100 for cohesive soils. Is that clear to you now? Is it clear now, man? So, yes, actually, why this question was very contradictory, because they have not mentioned the type of soil here. If they mentioned the type of soil, then this would have been another good question. But since it is not there, we were supposed to choose the right answer, most appropriate. So the most appropriate is what? It may be less than 100, it may be more than 100. This is also wrong, because this cannot be the always case. This is true, but not always true. This is also true, but this is also not always true. This is never true. So what is it? C is the right answer. Is it clear to everyone? Or should I explain it once again? Or shall we consider some more example about it? But according to me, this should be clear now. I have covered all the parameters. Islam, is the explanation clear now, bache? Yes, Islam. See, for design, it will again depend on n number of parameters. We cannot always say, we cannot conclude it by one single parameter, right? Okay, moving to the question number 16. This is the question number 16. Tell me the question number 16. Tell me, what is the right answer for this? Tell me, everyone. Who's going to tell me the answer of this? Who's going to tell me the answer of this? The answer for this is, please understand, what happens is in the negative skin friction, suppose this is a pile, right? Now this is resisting the load with the help of the skin. What will happen if this sand or this soil around this in this portion, if this is recently filled, if this is recently filled, or this is loose sand, or this is loose sand, then what will happen? This pipe will not be able to resist the loads with by the formation of bonds with it, and it will fall down. Once it will fall down, what will happen? Entire structure will fail. So the most appropriate answer is recently filled material. So this should be recently filled material. Should be the more appropriate. Is it clear, everyone? Is it clear? Now, let us move to the next question. The question number, let us move to the next question. That is your question number 17. Solve it, everyone. What is your question number 17? This is your question number 17. Solve it. Again, a question from negative skin friction. Again, a question from negative skin friction. Organic soil. Yes, that may be the case in the organic soil also. Tell me, everyone, tell me the answer for this. See, what happens is, again, I'll tell, suppose this is a pipe which is transferring the load by the help of scaling. What happens if this soil falls down? The weight is also, the load is also acting vertically downward. So this falling of the soil or losing the contact adds, suppose this was P1 and this is also falling down. So this will add to the load. This will add to the load, right? So it reduces the, very good all of you. So it reduces the what? It reduces the allowable on the part. So what is the more appropriate answer? B is the more appropriate answer, right? So net allowable load on the pile decreases. So write it here, net allowable load. So let us move to the next question. Is this one is clear, I guess? All right. So this is question number 18 of the day. Solve it. Solve it. The question number 18 of the day. Solve it. Yes, everyone. Tell me, everyone. You are going to tell me. See, what happens is the word to be chosen here is the word to be written here is uneconomical. Why? I'll just tell you. Uneconomical is the word to be chosen. This is a very old question. This was asked in 1995. This was asked in 1995. Right? What happens is, please try to understand. Underestimated. Okay, Johan, that is also acceptable. But for now, please understand, uneconomical is the word which I am using. Why? Because at shallow depth, the n value is underestimated. Right? Very good, Johan. Your answer is also right. At the shallow depths, what happens is, at the shallow depths, I have discussed in very detail in the class, the n value is underestimated. The n value is underestimated. So, what happens if something is underestimated? If something is underestimated, what will happen? It leads to the underestimation of the shear strength of the soil. Leads to the underestimation of shear strength of the soil. Shear strength of soil. Now, also, it leads to the underestimation of shear strength of the soil. Right? Now, if this is the case, what will happen? It results into the uneconomical design. Results to the uneconomical design. So, uneconomical design. So, when you are writing the underestimation, now, Chuhan, when you are writing the underestimation, we are not referring to the underestimation of any value or underestimation of the shear strength. If you are writing the uneconomical word, it is covering all other parameters, right? So this is why the most appropriate word here should be uneconomical. Is this clear, Chuhan and everyone? Is this clear, Bacho? Shall we proceed to the next question? Shall we proceed to the next question? Yes, clear, sir. Okay. So the next question here is question number 19. What is it? The most commonly used sampler for obtaining a distributed sample of soil is. Tell me. This is very common here. This is very easy. Not clear, sir? What happened, bache? Islam? Tell me. Just type your doubt in the comment section and I'll tell you. Okay. Islam, do you know what is n value, bache? What is n value? Do you know what is n value? Just work on the n values and then I will come back to you. Okay. Just type in the comment section what is n value and I will come back to this. Okay. Now, the most commonly used sampler for obtaining a distributed sample of the soil is your split spoon sampler is the most appropriate, right? All right, all right. So your A is the most appropriate answer. Is this clear to you? Right. Let us move to the now. If this is the SPT number, Islam. If you are considering at the shallow depths, that means we are underestimating it, right? If we are underestimating the value of n, okay, we are actually underestimating the shear strength of the soil, which makes the design uneconomical. This is a straight relationship, which is discussed in the notes also, right? So let us go back to the next question. Let us move back. Okay. The next question is question number 20. See, this is the maximum number of questions in a day we applied is today, right? We have applied 19 questions already, and this is the question number 20. So solve it. Solve it, everyone. Solve it, everyone. And then we will move to the next question. Try to solve it, and if you are not able to solve it, I will explain this, okay? Mechanical stabilization requires what? See, I'll tell you, mechanical stabilization is what? I'll tell you. This is generally not known to the students that mechanical stabilization is the one in which no chemicals are added. In the mechanical stabilization, no chemicals are added. Now, since no chemicals are added, what will happen? We have to mix something naturally. Naturally, two soils are mixed. Two soils are mixed for the purpose of stabilization. For the purpose of stabilization. For the purpose of stabilization. Now, what will happen? For the purpose of stabilization. Now, what will happen? I will just give an example. For example, this sand is mixed with the clay. Now, if I consider the sand is cohesionless or the cohesive? Sand is cohesionless or the cohesive? Who is going to tell me? Sand is cohesionless or cohesive? Now, if I'm mixing a sand that is cohesionless with the cohesive soil, now this is a particular purpose of the stabilization. I call this process as the mechanical stabilization. So, what is it? Mixing of two or more types of natural soils, addition of chemicals, no, addition of lime, no, addition of cementing material, no. So, this is your right answer. Is this clear to you, everyone? Is this clear to you, everyone? I've explained the entire concept to you. Shall we move to the next question? Islam, your doubt I'll cover in the next question. In this question, I will cover. This is why I did not discuss it there. Tell me. Tell me the answer of this. I'll cover your doubt also. Tell me. What is n value? I will tell you here. What is n value? I will tell you here. The concept of the n value I will tell you here. Just try to solve this particular question, right? Try to solve this question, everyone. Everyone is going to solve this. Very good, Pradyumna. Your concepts are very good now. You have just learned the notes very carefully, I guess, right? All right, I'll solve it for you, everyone. Very good. The number of blows are considered for the n is actually what? N is actually number of blows corresponding to last 300 mm penetration. Last 300 mm penetration. Now, if you see the last 300 mm penetration, this gives you the 150 mm and this gives you the 150 mm. So, what is the total number of blows? This is 8 plus 10, that is your 18 number of blows. 18 blows. So, where is the 18? The right option is C. Is this clear to everyone? Very good. Very good. Very good. Is it clear to everyone? Check. All right, everyone. All right. So, moving forward to the question number 22. Please try to answer it. Question number 22 for the day. Try to answer it. This is your question number 22 for the day. See, today we have applied 22 questions. 22 questions already, and we will be applying more questions today. I'll cover all the concepts of the foundation. I'll cover all the concepts of the consolidation. Now, this is also the soil exploration is covered here, right? All right, very good, all of you. Very good, all of you. So you have given the answers already. So this dilatancy correction is required only in case of saturated silt or fine sand. So this is required only in the case of the saturated silt or fine sand, which is your correct answer is C only, where aspect is greater than 15 after the overburden correction, right? So what is your right answer? The right answer is C. Okay. So this everyone has given the right answer because this is the very basic answer. Okay. Now the next question, we will be entering into the live quiz questions now. We will be entering into the live quiz questions now. How many of you are ready for the live quiz questions? How many of you are ready for the live quiz questions? We have applied 22 questions there and we will be applying 5 questions here now. Okay. We will be applying 5 questions here now. Okay. So in total, we are applying 27 questions in the class itself today. Okay, in the class itself, we are applying the 27 questions today. Ready? Ready? Very good, Islam. Greater than. Very good. Very good. All right. So this is the question number 1 for you. This is the question number 1 for you. Solve this question, everyone. What does the Terzaghi assumes? In the Terzaghi's one-dimensional consolidation theory, assumed that. What does the Terzaghi? Now is the Terzaghi coming? Now is the Terzaghi coming? Right? So what does Terzaghi assume? Terzaghi assumes that E is linearly proportional to P. Terzaghi assumes that E is linearly proportional to P. Now what is E and what is P? You must be knowing. Terzaghi assumes that E is linearly proportional to P. Now I'll tell you something. All of you, I'll tell you something. See, whenever I'm teaching the concepts here, no, there are chances that some of the parameters are unknown to you, some of the concepts are unknown to you. These classes are not to tell you the concepts in detail. Alright, bache, though I am covering everything in the possible details as much as it is possible, I am giving you. But these classes are targeted for the revision of those students who have covered the syllabus till this date, because this is December already, right? So those students who have not, please understand, those students who have not covered the basics and they miss a few concepts, it becomes your own individual duty to cover these concepts after the class, right? You just go after the class and understand and talk to yourself what is E, what is P. Sir mentioned this in the class and we do not know what is E and P. So this becomes your own duty. Because if I just start explaining everything, then this becomes the normal class. This will not no more be the revision class. Okay. Since these classes are the revision classes, there are certain parameters which I assume that you know. Okay. If this was the original class, I would have not assumed this. Alright, everyone. So I'm moving to the question number 2 of the day. In the live quiz, the question number 2. This is the question number 2. Just try to answer this. Try to answer this question, everyone. This is a good question I'm telling you. coefficient of consolidation is used for? Tell me everyone. Coefficient of consolidation is used for. Just read the question. Establishing the duration of primary consolidation, estimating the amount of settlement for a load increment, determining the depth to which the soil is stressed when loads are applied, determining the pre-consolidation pressure for soil deposits known to be over-consolidated. Tell me everyone. Time of primary consolidation. Very good. So what is the time of primary consolidation? What is the formula for time of primary consolidation? Formula for, I'll just explain for those who do not know. Formula for, what is the formula for? Tell me. Formula for time of primary consolidation. Primary consolidation. Now, what is this formula? This formula is PV is equal to CV into T upon. Who is going to tell me what is in the denominator? Who is going to tell me what is in the denominator? Okay, bache, I'll tell you in the last. Harsh, I'll tell you in the last. Don't worry. I'll tell you in the last. Upon D square. So in this formula, you can calculate the value of T. So this becomes your right answer. Harsh, I'll tell you in the last. Don't worry, bache. Okay. I'll tell you in the last. Okay. So moving to the question number 3 of the day. Question number 3 of the day. Please see this question very carefully and answer this. Very good. Bhageshri and Pradyumna, very good. See, those students who have given the formulas, they know almost everything. Okay. Harsh, you know what, bache, till the time everyone is answering this question, I'll just speak to you. Harsh Rathod, if we speak about the gate now, then if this was a university examination, now Harsh, I would have given you the exact topics as per your university that they will be asking these particular questions. But the gate is so unpredictable, it becomes really difficult to tell you exactly what are the important topics, right? Number one. Number two. But yes, on the basis of the previous year papers analysis, we can tell that like one topic consolidation. Gate is asking so many questions from this. The first topic, see Harsh, if you are a beginner, I'll just tell you, you focus on the index properties and the first two chapters of this particular subject. If you focus on the first two subjects of this particular subject now, till the index properties, right, you will be able to score at least 3 to 4 marks. And that is more than sufficient for someone who do not know anything. But if you are at the intermediate level, then focus on the index properties, focus on the seepage analysis, focus on the consolidation, right? Focus on the shear strength. If you do these 4 or 5 topics, you are through it. Getting it, Harsh? I hope I am able to convey things to you. Anyways, now coming to this, bache, coming to this for everyone, right? Now, since we have written the formula already, since we have written the formula already, 50% of the consolidation at a site subjected to a stress level of this occurred in 2 months. If the site had been loaded to 400 kilopascal, 50% of the consolidation would occur in 4 months. Now, is this true or false? Is this true or false? Who's going to tell me? Okay. See, please understand this is false. Why? Because if I want to write this formula, no? We have written this formula already. This formula. This TV can also be written as pi by 4 u square is equal to CV into T upon D square. This formula can be written as this also. This formula can be written as this also, right? So since this CV upon D square, since this CV upon D square remains same in the present case, we can say that T is the small t. This T is proportional to U square in this case. Using this formula, can we say that T is proportional to u square. Now, if t is proportional to u square, if dt is proportional to u square, what will happen? What will happen? As u is given same, that is 50%, t also remains same. U is given same, that is 50%. This t also remains same. I hope this question is clear to you now. I hope this question is clear to you now. Only that formula is used here also. That previous formula is used here also. Okay. All right. Moving forward to the next question. I hope this is clear to everyone, each and everyone out there. All right. Moving forward to the next question. That is question number 4 for the day. Live quiz questions. Question number 4. Okay. Solve this question. The slope of the, I'll show you the graph. The slope of the, actually I have already shown you the graph. What is the value of CC? What is the value of CC? Coefficient of compression index. What is the value of CC? Now, do not check your notes, you will get it. Check your notes, alright? Work on it yourself. Since I know you, if there was some random student on the YouTube, I would have explained this. But since this is you, and I've explained it in the class, I'm going to be explaining it here. Okay, bache? Okay. Now, someone is writing C, someone is writing B. The right answer is C. Let me reveal the concept first. This is C only. Now, please try to understand if I see this graph. Pradyumna, see this question. All of you know this graph. We have just discussed this graph. What were the values which we discussed? What were the values which we discussed? We had the values E naught and EF. We had the values. Suppose this is the E naught. Suppose this is the sigma dash naught. Here we have some value sigma dash F. And this is the value of the EF. You have seen this formula now? You have seen this formula now, bache? We just made this. So what is the value of CC? The value of CC was equal to the value of CC we just discussed. This was equal to E naught minus EF upon log base 10. Log base 10. So this is always on the log base 10. This is on the log scale, right? Sigma. So this is log base 10 of the sigma dash. Right? So this F will not come. So this is, I'll just make it. Alright, so this is log base 10 of the sigma dash, and here what we have, this is E only. So this is log base 10 of sigma dash F upon sigma naught. This is the formula for CC. If this is the formula for CC, the compression index, right? The slope of the E log P curve is giving you what? This is E log P curve. What is this giving? This is giving you the CC. What is it? This is the coefficient. This is the coefficient of compression index. Is this clear to everyone? Is this clear to everyone? All right. So I have given you the formula again. Let us enter into the last question of the day. Let us enter into the last question of the day for the quiz. This is the last question. Solve it. Sand drains. Tell me. If I want to write about the sand drains, before you answer this, I will write a few things about the sand drains. Now, what are sand drains? I will just write a few things about the sand drains. Alright, bache? Okay, then you can answer it. First, understand these few things about the sand drains. The very first thing sand drains will do is, I have again written anyways. So, very first thing they are doing is pre-consolidation of soil. They are used for pre-consolidation of soil. Now, what is the pre-consolidation of soil? In the process of pre-consolidation of soil, what will happen? Very good, all of you. All of you are answering it wrong. Let me tell you. all of you are answering it wrong. Okay, let me write the concept and then you can answer. I know it already that you will be writing it wrong. Okay, so let me make things. So this is used for the pre-consolidation of soil. Pre-consolidation of soil, right? So what is the meaning of the pre-consolidation of soil? This is a ground improvement technique. This is a ground improvement technique. How the ground is improved? How the ground is improved? Please understand the process. Right, next. All of these can be the questions, independent questions. But please have patience to understand this. Okay. Now, the sand rains accelerate the consolidation. Sand rains, they accelerate the consolidation. These sand rains accelerate the consolidation. How they accelerate the consolidation? The next step, they accelerate the consolidation. How they accelerate the consolidation? They accelerate the consolidation by reducing the drainage path. By reducing the drainage path. They reduce the drainage path. If they are reducing the drainage path, they are also resulting into the increasing the permeability. Increasing the permeability. Yes or no? So I'm not saying that this is wrong. I'm not saying that this is wrong. I'm not saying this is wrong. Whatever you have answered is right. So sand rains are doing all these purposes. They are increasing the permeability also. But the more appropriate answer is what? The more appropriate answer is what? They are accelerating the consolidation. The main purpose, see, you have to be very tricky while answering these questions. The main purpose of building the sand drains is to accelerate the consolidation, not to increase the permeability. Not to increase the permeability. The main purpose of sand drains is not to increase the permeability. The main purpose is to accelerate the consolidation. Yes, though this acceleration is done by increasing the permeability only, but what is the purpose of building the sand drain? What is the purpose of the sand drain? The purpose is accelerating the consolidation. I hope this is clear to everyone. That why the right answer is B. I hope this is. Yes, it is confused. Yes, it is given to confuse you only. This is also right, but the more appropriate answer is B. Why? I am explaining it for the third time. The sand drains are built not to increase the permeability but to accelerate the consolidation. Is that clear to you? Is it clear to you? Is that clear to you? Very good, all of you. Very good, very good, very good, very good. Very good. So both are right. Okay. So both are right, but it is increasing the permeability, but it is accelerating the consolidation. So the purpose of building the sand drains is not to increase the permeability. The purpose is to accelerate the consolidation, right? All right, bache. Now this is it for the number of questions for the day, right? This is it for the number of questions for the day. Now I'll just write a few things here. Geotech is tricky but easy. Contradictory statement. So geotech is a bit tricky but easy. Once you will be able to know all the concepts, you will be able to solve everything. Alright, now geotech is tricky but easy. Second, trust your concepts. Trust your concepts. Whatever is with you, trust your concept. One or two answers may not match from the theory. One or two answers may be wrong. You have to trust your concept. And at the last, all the best for this subject. We are left with the subject of the environment and surveying and irrigation hydrology. But for now, this is it for this particular subject. Alright, bache? Capacity and pressure are the chapters in itself. Now, capacity and pressures are the chapter in itself, right? So, so, and talking about the capacity and pressure in the foundation in particular, we have covered all the rigid, flexible, and all those concepts in the yesterday's class, that is dated by 16th of December. Alright, Islam. So if you want to see that, you can see that video. If you still face the problem, you can type it in the comment section. I'll give you the link of that particular video. Alright, bache? So everyone, this is it for this particular session, right? I hope you will be joining the environment sessions also, and I'll bring up the environment session soon. So this is it for this session, everyone. Pradyumna, the main topics. I hope you will be joining the class tomorrow. Pradyumna. But for those who will not be joining the class, the main topics are index properties. See, the index properties is the soul of the. I have given you in all the formulas separately talking about the soul of the soil, right? So, index properties, consolidation, shear strength, seepage analysis. These are the topics which you need to focus, everyone. All right, everyone. All right. So this is it for this session, everyone. God bless you all. Islam देखा हूँ but clear नहीं हुआ. बच्चे see, this is not this time is bounding me. I wish I could explain the entire thing again. Do we have these slides? No, we do not have these slides. Anyways, but I'll still try to explain. I'll just still try to explain it to you, bache. We had two type of footings. I gave the entire theory in the yesterday's class. I don't know why you failed to explain this. Anyways, so you are talking about the if this is a flexible footing or this is a rigid footing. We covered this entirely yesterday. This is a flexible footing or this is a rigid footing. So there are two things to be considered. One is the settlement and another is the pressure. This is what you want to ask, Islam. This is what you want to ask, bache. This is what you want to ask, my bache. Right? I have given you exactly all the things related to this in the previous class, right? Fine. So this is it for this session, everyone. Everyone has left. Now we can leave this, Islam. For now, if you want to reach me out, just Google it up. Civil Engineering by Ankur Malik. You can reach me and I'll share the notes and the videos with you for related to that. Okay. Okay, everyone. So this is it for this session. The time is already over. God bless you all. Do take care of yourself. Thank you, sir. Best faculty. Bache, we are meeting tomorrow again for the classes. Bye-bye. God bless you all. And please do join for the environment sessions, everyone. Bye-bye. God bless you. Good night, everyone. Take care.
Hello students, thank you so much for watching the session. We hope you enjoyed this session a lot and there are many more sessions to go.
So do like, share and subscribe to our YouTube channel, and this GATE score booster will definitely boost your score. So thank you once again.
Hello students, thank you so much for watching the session. We hope you enjoyed this session a lot and there are many